Okay, here's another example that we're going to do where instead of giving us all of the data, they're just giving us the sample size, the sample mean, and they ended up giving me the standard error of the mean, but I wrote in the standard deviation because that's typically what I'm going to give you. So why don't you pause the video and read through this question, and then we'll go over what they're asking us to do. Okay, so in this problem, you'll notice that we have two samples of size 25. And then you'll also notice in this problem they talk about proportion because they looked at the proportion of times participants indicated they were zoning out, but we actually averaged all those proportions. So when we're looking at our mean, we're dealing with the mean of those proportions for the 25 subjects in each group. Okay, so this is a mean problem, not a proportion problem. I told you that I would give you the standard deviation, the sample standard deviation. I'm not going to give you the standard error of the mean when I give you a problem like this. So I already have a table. I'm just going to label it this as my group 1 and this is my group 2 so that we can be consistent and not get them confused. Okay? So part A was finding the sample standard deviation, which I already gave you. Part B was to come up with the degrees of freedom using the conservative option 2. So if you remember, it's going to be the 25 minus 1 or 25 minus 1 in this case. So we're going to get degrees of freedom equaling 24. Okay? Now, if I use the conservative option, then I'm doing the confidence interval by hand for part C because they're asking me to give a 90% confidence interval. Notice this is not a test of hypothesis. This is, I want to estimate the difference in the mean times or the mean number of times that the subjects zoned out. So I'm going to do this by hand first, and then we'll actually use our calculator. And you'll see our answers are very, very similar, even though our degrees of freedom are going to come out differently. So when I do a confidence interval, I need to take my x1 bar minus x2 bar plus or minus, I'm going to use the t sub 24 square root of s1 squared over n1 plus s2 squared over n2. Okay, it's not really that bad to do this by hand. So I have 0.25 minus 0.12 plus or minus. Now, I'm going to go to my t-table and I come up with the 1.711 for a 90% confidence interval with degrees of freedom of 24. And you can look at your t-table to figure that out. But I have 0.25 squared divided by 25 plus 0.15 squared divided by 25. So when I put this into my calculator, I get 0.13, and you may want to pause this video and put it in there, plus or minus 0.0998. So that confidence interval is going to be 0.0302, 0.2298. And I went to 4 digits on this one, partly because of the 9 on the end. I didn't want to round that all the way up. Okay, so what does this mean? It means that I am 90% confident that the difference in the proportion of times that the subjects zoned out while reading Tolstoy's War and Peace is somewhere between 0.03 and 0.2298. Okay, and that would be for all the subjects if I looked at all people ages 21 to 35, the ones that had alcohol and the ones that did not. Okay, so now you'll notice here my margin of error is the 0.0998. Okay, and when you do it by hand, you see what the margin of error is. Let's do this on our calculator and then come up with what our margin of error is when we use our calculator. So I'm going to go to the stat, test, and this time I need to go down until I get to 0. And at 0, it's going to say 2 sample t interval. Okay. Once again, they're going to ask for a whole bunch of information, all of the information that's given in that table. And I just need to enter that information and make sure you do pooled no. And you'll come up with this confidence interval if I round it to 3 digits. Okay. So the other thing you'll notice that it gives me a degrees of freedom of 39.3. Is this interval wider or narrower than the one I came up with by hand? And why would that be? Think about that for a few minutes. We can also, what would be our margin of error? What would I get in this particular problem? We know that the difference between the two means is 0.13. So my margin of error is going to be the 0.228 minus 0.13, which gives me 0.098. Okay, which is obviously a little bit smaller than what I came up with for the one by hand. Okay, and if you remember, my degrees of freedom were 39.3 here, where it was only 24 when I did this one. Okay, and what happens to my t-value as my degrees of freedom increases? Remember, my t-value gets closer and closer to what our z was, which means it gets smaller. Therefore, my interval is a little bit smaller. Okay, for this example, notice that we just did a confidence interval. I did not do a test of hypothesis. So when you look at this confidence interval, what does it exactly mean? It means that I am 90% confident that the difference in these means, population means, are going to fall between 0.03 and 0.22 or 0.23 if I round it up. Okay, so if I had to draw a conclusion, would I say that the alcohol affected your proportion of times that you zone out while reading in this particular case? Why or why not? Okay, look at your confidence interval and see if you can come up with some sort of conclusion. And before I answer that question, let's just set up a test. Let's say I was going to do a test and I need to set up my null and my alternative. Remember, my null would be that the means are equal, and my alternative is I would guess that you'd probably zone out more if you had alcohol than without alcohol, so I'm going to say greater than on this one. Okay, so if I set this up, I'm saying if the means are equal, what should be contained in my confidence interval? If I take the difference of those two sample means, I should probably get 0, somewhere in that confidence interval, or the population means. I should probably get 0 somewhere in that confidence interval if there was no difference. Okay, and I didn't. I ended up getting all positive numbers. So if I actually go on my calculator, remember we do our stat test, and this is going to be number 4. And remember, no pooling. If you go through and actually do this, you'll get a t of 2.23 and a p-value of 0.016. So in this case, at an alpha equals 0.05, we would reject. And we would be able to say that the alcohol does make somebody zone out more while reading Tolstoy's War and Peace. If my alpha was much smaller than that, at let's say 0.01, then I would not have enough evidence to actually reject that. But this is consistent with what I came up with my confidence interval, because neither one of those confidence intervals, whether by hand or using the calculator, gave me 0 as far as the difference. Okay, and so if 0 is not in there, most likely I would be rejecting my null, because my null is basically saying that the difference is 0. Okay, so that's basically the end of this lesson. I would strongly recommend that you practice organizing the information that's given in some of these paragraphs. There's a lot of information. Sometimes a table will be given, sometimes it won't be given. You'll have to pick out the information from the paragraph. I like writing down or setting up a table with like S1, X bar 1, and N1, and so on, because it helps with organizing into your calculator as well. So definitely practice these. The interpretations of your answers, if you've noticed, are very similar to what we did with one samples. So the hardest part is getting used to putting the information into the calculator and organizing it. So our next lesson will be dealing with a z's instead of the t's, and it is a little bit shorter but more practice of the same thing.